Alright, so today we're going to be going over exponential functions. So the function f of x defines an exponential function for each constant b, where b is called the base. So far in class we have gone over lots of linear equations, and we have gone over parabolas, but today we're going to be introducing what we call an exponential function, where a function is going to be growing at the same rate for the entire time, or it might be decaying at the same rate for the entire time. So let's draw a couple more examples. So this would be y equals to b raised to the x, where b is greater than 1. Alright, so let's talk about this base. Let's talk about b. So b is just going to be some number, like maybe 1.5 or 10. And we're going to be raising that base to x. Alright, so this was for when b is greater than 1. When b is between 0 and 1, it looks like a decaying function, where y equals to b raised to the x, where b is between 0 and 1. And note that both of these cross through the y-axis, where y equals to 1. Alright, so let's talk about some properties of exponential functions. One, if we have a raised to the x times a raised to the y, well, this will equal to the a to the x plus y. So here we're just denoting x and y as two separate numbers, and we still have the same base. So a raised to the x times a raised to the y, well, that's just going to equal to a to the x plus y. So for example, if we have 2 raised to the 5 times 2 raised to the 7, well, since they're of the same base and we're multiplying by each other, this is the same thing as a raised to the 5 plus 7, or 13. It's 12. Sorry for that mistake. Alright, the second property, we have a raised to the x divided by a raised to the y. Well, that's simply going to be a raised to the x minus y. Third property, if we have a raised to the x raised to the y, well, that's going to equal to a raised to the x times y. Fourth property, if we have the fraction a over b, all raised to the x, well, that equals to a to the x divided by b to the x. If we have a times b, all raised to the x, well, that equals to a to the x times b to the x. And 6, if a to the x equals a to the y, why then we know that x equals y. Similarly, if a raised to the x equals to b raised to the x, why then a equals to b. Alright, so that's some nice properties where we're going to be using when dealing with exponential functions. Alright, so let's deal with one of the more common ones that we're going to be using. Is we're going to be dealing with continuously compounding interest. So this is a situation where we put money into the bank, and maybe into an account, and that account is going to accrue interest over time, and over time the interest that was accrued in previous time periods is going to accrue interest as well, and we are going to be continuously compounding our interest that we're earning. So the equation we're going to be using is A equals to P-E-R-T. This is the R. Alright, where A equals to the amount. How much money are we going to have in the account after the whole thing is done? P, we call our principal, which that's just going to be the original amount that we put into the investment. So maybe if we put $5,000 into the account, that from day one, well, the principal is going to equal $5,000. R equals to the annual rate. So what is the interest rate that we're going to be accruing on this account? And this time will equal T equals to the time, how many years has passed by. And then E, well, this is just a constant. It is roughly 2.718. Similar, we are more familiar with the constant pi in mathematics, where we're dealing with maybe the circumference or the area of a circle, like that equals to 3.14. E is also just a constant, where it equals to the number 2.718. And E should be on each one of our calculators that we'll be using in this class. Alright, so let's do an example. Let's say we put $10,000 or $1,000 into an account, so that's going to be our principal. Our annual interest rate will be 0.05, or we might simply just say 5%. Our T will equal to 1, so we're going to invest in for 1 year. And then we want to know how much we will have in the account at the end of 1 year. So we're going to take this information and plug it into this formula that we have. So we'll have A equals to 1,000 times E raised to the 0.05 times 1. Alright, so we are going to plug in E raised to the 0.05 into our calculator, and we're going to get A equals to 1,000 times 1.0527, I believe. And then note that this 1.0527, well, that is simply what E raised to the 0.05 is equal to. Alright, now that we know that we have 1,000 times 1.0527, well, A will equal to $1,000 and $51.27. Alright, so that would be how much money is in our account at the end of 1 year, given that we invested $1,000 to begin with. We had an interest rate of 5%. We invested it for 1 year. Alright, another example of using exponents. So we're going to be doing compounding interest, where we're going to say A equals to P times 1 plus R divided by M raised to the MT. So this is going to be another situation where we're going to be putting money into an account, and it's going to be accruing interest over time. But instead of that interest being accruing continuously every moment of every minute of every hour of every day, it's going to be accruing interest at set periods of time, where M is going to be denoting how many times per year that we are going to be accruing interest. Alright, so once again, we have A equals to the amount in the account at the end. P is going to be our principal again, so our original investment amount. R, once again, is the annual rate. And M equals to the amount of times compounded per year. So if we hear that our account is going to be compounded monthly, then we know that M will equal to 12. If we hear that our account is going to be compounded daily, then we may say that m equals to 365. If we say that our account is going to be compounded biannually, say twice a year, then we know our m equals to 2. So it's just the number of times per year that our account is going to be compounded. And then, of course, t equals to time again. How many years did we have an investment? All right, so let's do another example. Where let's say that we are going to invest $5,000 into an account that has an annual rate of return of 9%. And we are saying that it's going to compound monthly. So given that it compounds monthly, that tells us that m equals to 12. And then we are going to make an investment for 5 years. So that way we know that time equals to 5. And once again, we want to know how much is going to be in the account at the end of 5 years. So we're going to take this information about P, R, M, and T, and we're going to plug it into this equation. Alright, so we're going to have A equals to 5,000 times 1 plus 0.09 divided by 12, all raised to the 12 times 5. So all I did was plug in the values that we have for P, R, M, and T into the equation. Alright, so now we're going to have to do some math and use our calculator to figure out some of these values. So first, I say we deal with what's inside this parentheses at first. So we're going to have A equals to 5,000 times 1.075, all raised to the 60. Nope, the 1.075, well, that is simply going to be 0.09 divided by 12. And then the 60 is the 12 times 5. Alright, so now we're going to want to solve for this part here. What is 1.075 raised to the 60? Well, we're going to have to plug that into our calculator. And we are going to get 1.57. So 1.57 is 1.075 raised to the 60th power. And then we know that A equals to $7,828.41. So that's how much money is going to be in our account at the end of 5 years. We originally invested $5,000. At the end of 5 years, we're going to have $7,828.41. So that's how much going to be there. And then we can ask, hey, during the duration of this investment, how much did we earn in interest? Interest earned. Well, the interest earned is simply going to be the difference in how much we ended with minus how much did we originally invest. So the interest is going to equal to the final amount minus how much we originally invested. So for us, we're going to get $7,828.41 minus 5,000 will equal to $2,828.41. So that is how much money we have earned in interest over the entirety of the 5 years. Alright, so that sums up our short explanation about dealing with exponents.